Good day everyone, welcome to my YouTube channel. In this video, we will talk about the graphical method in solving linear programming problems. We need to define first what is linear programming. Linear programming is the technique of optimizing, either maximizing or minimizing a linear function of several variables subject to a number of constraints stated in the form of linear inequations or equations. There are basic elements or components of linear programming. We have the decision variables, the objective function, the constraints, and the non-negative restriction. For linear programming problem having only two variables, the set of all feasible solutions can be displayed graphically by determining the feasible region. So problems involving more than two variables cannot be solved graphically. There are two techniques of solving a linear programming problem by graphical method. We have the corner point method and the isoprofit or isocost method. We shall discuss and use only the first technique. The corner point method. This method is based on a theorem called extreme point theorem. The optimal solution to a linear programming problem, if it exists, occurs at an extreme point or a corner of the feasible region. Here are the steps in solving a linear programming problem graphically. First, formulate the LPP or linear programming problem. Second, construct a graph and plot the constraint lines. Third, determine the valid side of each constraint line. Fourth, identify the feasible solution region. Fifth, find the optimum point. An optimum point always lies on one of the corners of the feasible region. Sixth, calculate the coordinates of optimum points. Last, evaluate the objective function at optimum points to get the required maximum or minimum value of the objective function. For example, solve the linear programming problem graphically. Maximize z is equal to 5x plus 3y, subject to the constraints 3x plus 2y is less than or equal to 12, that is constraint 1, and x plus 2y is less than or equal to 8, that is constraint 2. X and y is greater than or equal to 0. As we can see in our example, there are only two variables, the x and y. So our solution here, and the mathematical formulation of the linear programming problem is already given. The non-negativity constraints, the x is greater than or equal to 0 and y is greater than or equal to 0, imply that the feasible region is in the first quadrant only. So we need to construct a graph and plot the constraint lines. First, we need to find any two distinct points on the line and draw a straight line through them. For convenience, choose one point on x-axis by putting y is equal to 0 and the other on y-axis by putting x is equal to 0. So we need to treat each constraint as the linear equation. In constraint 1, if x is equal to 0, then 3x plus 2y is equal to 12. 3 times 0 plus 2y is equal to 12. Then simplifying, divide both sides by 2. We have y is equal to 6. We have p sub 1 is equal to 0, 6. If y is equal to 0, 3x plus 2y is equal to 12. Then 3x plus 2 times 0 is equal to 12. Then divide both sides by 3. Then 12 divided 3 is equal to 4. So we have p sub 2 is equal to 4 and 0. So the intercepts for the line 3x plus 2y is equal to 12 are the p sub 1, 0, 6, and p sub 2 is equal to 4, 0. So we need to plot the coordinates. In constraint 2, if x is equal to 0, we have x plus 2y is equal to 8, then 0 plus 2y is equal to 8, then simplifying, we have dividing both sides by 2, so we have y is equal to 4. We have q sub 1 is equal to 0, 4. If y is equal to 0, x plus 2y is equal to 8, then x plus 2 times 0 is equal to 8, then x is equal to 8. We have q sub 2 is equal to 8, 0. The intercepts for the line x plus 2y is equal to 8 are this q1, 0, 4, and q2, 8, 0. After plotting the constraint lines, we need to shade the common region that satisfies all the constraints. And we identify the feasible region, this shaded part with the corner points, A at 0, 0, B at 4, 0, and C is unknown, D at 0, 4. So find the point C, we need to use the constraint 1 and the constraint 2. If we have 3x plus 2y is equal to 12, then we need to get the value of x. So by addition property of equality, we have 3x is equal to 12 minus 2y. Then divide both sides by 3, we have x is equal to 12 divide 3 is equal to 4. Then 2 divide 3 is 2/3 y. Next, we will use the constraint 2. We have x plus 2y is equal to 8. So we have the value of x, which is 4 minus 2/3 y plus 2y is equal to 8. Then, by addition property of equality, we have negative 2/3 y plus 2y is equal to 8 minus 4. Then, simplifying this fraction, so 2 times 1 is 2, then 3 times 2 is equal to 6, then negative 2 plus 6 is equal to 4. Then 3 times 1 is equal to 3, so we have 4/3 y. So 8 minus 4 is equal to 4. Dividing both sides by 4/3, we have y is equal to 4 times 3/4. 4 times 3 is equal to 12, divided by 4 is equal to 3. So we have y is equal to 3. So we need to substitute this value y is equal to 3 to this equation. So we have x is equal to 4 minus 2/3 times our value of y, which is 3, times 3. We have 4 minus 2 times 3 is equal to 6. Divide 3 is equal to 2. So we have x is equal to 4 minus 2. So 4 minus 2 is equal to 2. So our x value is equal to 2. So we have now the point of C. The x is 2 and the y is 3. Since the optimal value of the objective function occurs at one of the corner of the feasible region, and we already determined their coordinates. So we need to find the value of the objective function z is equal to 5x plus 3y at each corner point. We have corner point A, B, C, D, and the coordinates. The coordinates of A is 0, 0. The coordinate of B is 4, 0. The coordinate of C is 2, 3. Coordinate of D is 0, 4. Value of objective function at point A, 5 times 0 plus 3 times 0 is equal to 0. Then at point B, 5 times our x is 4 plus 3, our y is 0. So simplify, 5 times 4 is equal to 20. At point C, 5 our x is 2 plus 3, our y is 3. So 5 times 2 is equal to 10 plus 3 times 3 is equal to 9. So 10 plus 9 is equal to 19. At point D, 5 our x is 0 plus 3 our y is 4. So 5 times 0 cancel out, then 3 times 4 is equal to 12. The largest value of the objective function, that is our maximum value. So the maximum value of z is 20 at the point B, 4, 0. Hence, the optimal solution to the given LP problem is x is equal to 4, y is equal to 0, the maximum z is equal to 20. And the minimum value of z is 0 at the point A, 0, 0. That's all for this video about linear programming by graphical method. Thank you for watching.